Very good evening to one and all. And today in this session we are going to discuss about one important topic from second module, which is the transmission of power. So under this topic we are going to discuss about the belt and chain drives. Let us move to the discussions directly. So before going to start, what is meant by power transmission, or what is the use of power transmission elements? So it is well known that the rotational motion has been found to be the most ideal and simplest means of transmission of mechanical power. The rotational motion has been found to be the most ideal and simplest means of transmission of mechanical power, which means the rotational motion can be transmitted from one mechanical element to the other with the help of certain systems known as transmission systems or drives. Okay, so the rotational motion can be transmitted from one mechanical element to the other with the help of certain systems known as transmission systems or drives. Okay, sometimes these systems may be employed to drive a device directly by a prime mover or transmit the rotational motion to the various parts of the machine within itself. Okay, so the one that drives is called a driving system, and the other which is driven is called the driven system. And usually round rods called shafts are employed to transmit the rotational motion. Usually the round rods called the shaft are employed to transmit the rotational motion. So the mechanical power can be transmitted from one shaft to another, generally by four methods. That is, four methods of mechanical drives. That is, belt drive, rope drive, chain drive, gear drive. Okay, the shaft from which the power is transmitted is called the driver shaft, and the shaft to which the power is transmitted is called a driven shaft. ഇതെല്ലാ ടെർമിനോളജിക്കകത്തും നമ്മൾ ഈ ഒരു കോമൺ ആസ്പെക്ട് ആണ് ഫോളോ ചെയ്യുന്നത്. ഷാഫ്റ്റ് ഫ്രം വിച്ച് ദി പവർ ഇസ് ട്രാൻസ്മിറ്റഡ്. നമ്മൾ നേരത്തെ ഡ്രൈവിംഗ് സിസ്റ്റം ഡ്രിവൺ സിസ്റ്റം പറഞ്ഞതുപോലെ തന്നെ the shaft from which power is transmitted is called the driver shaft, and the shaft to which power is transmitted is called the driven shaft. Now, so എങ്ങനെയാണ് ഏത് ഡ്രൈവ് ആണ് നമുക്ക് വേണ്ടത് എന്നെങ്ങനെ ചൂസ് ചെയ്യുക? ബെൽറ്റ് ഡ്രൈവ് ആണോ, റോപ്പ് ആണോ, ചെയിൻ ആണോ, ഗിയർ ഡ്രൈവ് ആണോ, ഏതാണ് suitable? So the choice of the type of the drive for transmitting the power from driving shaft to the driven shaft depends on many factors. എന്തൊക്കെയാണ്? Distance between the shafts, amount of power to be transmitted, speed ratio of shafts, accuracy required, etc. Okay, so all these aspects depends. So let's start discussing about one by one. First we are going to discuss about the belt drives. So the belt drives are one of the common methods generally employed whenever power or rotatory motion is to be transmitted between two parallel shafts. Okay. So whenever power or rotary motion is to be transmitted between two parallel shafts, or whenever power is to be transmitted from one shaft to another which are at considerable distance apart. we generally use a belt drive. Okay, so the schematic picture which is shown in this slide, we can see that it consists of two pulleys over which an endless belt is passed encircling both of them. Okay, that is the mechanical power or rotary motion is transmitted from driving pulley, you can see the driving pulley, to the driven pulley. Why? How? Because of the frictional grip that exists between the belt and the pulley surface. Okay. So I hope you can understand the friction that is existing. Because of this frictional grip, the power is transmitted. So you know well that in many of the general engineering practice, the friction is undecided. But in belt drives, it serves as a helpful agent. Obviously, for the belt drive to move, the pull or tension on one of the sides of the belt should be more than the other. So for the belt to roll over these pulleys or for the belt to move, the pull or tension on one of the sides of the belt should be more than the other side. The portion of the belt which is having less tension is called slack side, SLACK. You can see that is given in this diagram. And the portion of the belt has higher tension called tight side. Of course, നമുക്ക് രണ്ട് വേർഡിംഗിൽ നിന്ന് തന്നെ മനസ്സിലാവും. ടൈറ്റ് സൈഡ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ടെൻഷൻ കൂടുതലാണ്, സ്ലാക്ക് സൈഡ് ടെൻഷൻ കുറവാണ്. Okay, so the effective pulling power of the belt that causes the rotation of the driven pulley is the difference in tension on slack side and tight side. Okay, hope you understand the demonstrations. We move on to the next slide. Yeah, as I told you, the pulleys are mounted on a driver and driven shaft, and an endless belt is fitted tightly over these pulleys. The factor responsible for power transmission is the frictional resistance between the belt and pulley. And then the amount of power transmitted, depends upon the velocity of the belt, the tension under which the belt is placed on the pulleys, the arc of contact of the belt and the smaller pulley. ഈ മൂന്ന് ഫാക്ടേഴ്സ് എത്രമാത്രം പവറിനെ ട്രാൻസ്മിറ്റ് ചെയ്യണം എന്നുള്ളതിനെ ഡിസൈഡ് ചെയ്യുന്നു. So these three factors. Okay. Now let's see what are the different type of belts. There are many type of belts for transmission of power, but in general the flat belts and V belts are widely used. What is meant by flat belt, or why flat belts, or why V belts? The flat belts are used to transmit moderate amount of power. Whenever you want to transmit moderate amount of power, it is preferable to use flat belt. It is used up to 10 meter distance between the driving and driven shafts. Then V belts are more suitable for transmission of large amount of power between two shafts having short center to center distance. The ideal distance is 1.25 to 1.5 times of the diameter of the larger pulley. Okay, the belts which is used for the power transmission should fulfill these requirements which is highlighted in this box. It should have larger strength, flexibility and life, and high coefficient of friction. Now let's also see what are the different type of belt materials. The belt materials, the power transmission belts are generally made from leather rubber, canvas, balata, and cotton or fabric. So the leather belts are made from hide, which means cow hide, or there are many type of hides. Okay, so the leather belts which can be used in both dry and wet conditions. Another type of belt is the rubber belts, are used when the belts are exposed to damp conditions, or it requires damp conditions. It is preferable to use rubber belts because it can absorb lot of shocks. Then canvas belts are used when the atmospheric conditions affect a leather belt or rubber belt. Then another type of belt is balata belts, which are made from cotton and balata. It is supposed to be 25% more stronger than rubber belts. Now let's look into different type of belt drives. There are mainly two types. One is open belt drive and closed belt drive. Cross belt drive. Open belt drive and cross belt drive. In the case of an open belt drive, this type of belt drive is used when shafts arranged in parallel and to be rotated in the same direction. So it is used with the shafts arranged in parallel. You can easily see in this picture. This is shaft number 1, shaft number 2, and it is used when the shafts are arranged in parallel and to be rotated in the same direction. Here, the driver pulley pulls the belt from one side and delivers the same to the opposite side. So hence the tension on the former side will be greater than the later side. The side where the tension is more, we already discussed, it's called tight side, and the other side is called a slack side. Okay, so also we can say the open belt drive is employed when the two parallel shafts have to rotate in the same direction. Keep this point in mind. Two parallel shafts have to rotate in the same direction. Okay, then is crossed belt drive. We are going to discuss about the crossed belt drive. It is used with the shafts arranged in parallel and to be rotated in opposite directions. Okay, so when two parallel shafts have to rotate in opposite direction. So if you look at this schematic setup, you can see that at the junction where the belt crosses, the belt, that is, it rubs against itself and wears off. To avoid excessive wear, the shafts must be placed at a maximum distance from each other and operate at low speeds. Another important phenomenon in belts is the slip-in belt drives. If you look at there is one of the very important expression, delta T is equal to mu R. So which means that the difference between the tensions in the tight side and slack side, that is delta T, okay, of the belt equal to the force of friction, that is mu into R, where mu is a coefficient of friction. Okay, so if delta T is greater than mu R, or in other words, when this, so if delta T is equal to mu R, so when that condition exists in a belt drive, the friction between the pulley and the belt in contact with, which means the belt in contact with it, will provide the necessary frictional grip to prevent the sliding of the belt over the pulley. Okay, the friction exists, the sufficient friction exists. Suppose the difference between the tension in the tight side and slack side of the belt is greater than the force of friction, that is delta T greater than mu R, then the belt begins to slide over the surface of the pulley. The sliding of the belt, which causes a relative motion between the pulley and belt, which is called the slip. Very important. The sliding, belt slide of നമ്മുടെ ഈ പുള്ളിയുടെ മുകളിൽ നിന്നും. എന്തുകൊണ്ടാണ്? ഈ ടെൻഷൻ ഫ്രിക്ഷനേക്കാളും കൂടുതൽ വരുന്ന കേസുകളിലാണ്. So the sliding of the belt which causes the relative motion between the belt and pulley is called the slip. Another important terminology associated with belt drive is the velocity ratio. So the velocity ratio of the belt drive is defined as the ratio of the speed of the driven pulley to the speed of the driving pulley. So for example, let D1 and D2 be the diameters of the driving and driven pulleys, and let N1 and N2 be their speed in revolutions per minute, and if there is no slip between the pulleys and the portions of the belt which are in contact with them, the speed at every point of the belt will be same. Very important point. If there is no slip between the pulleys and the portions of the belt which are in contact, the speed at every point of the belt will be same, which means equal to linear speed of the belt is equal to circumferential speed of the driving pulley, which is equal to circumferential speed of the driven pulley. So which means pi d1 n1 is equal to pi d2 n2, which is equal to d1 n1 is equal to d2 n2. So the velocity ratio എന്ന് പറഞ്ഞ ഇതാണ് n2 by n1 is equal to d1 by d2. Very important expression. You remember this expression. n2 by n1 is equal to d1 by d2. ഇനി നമ്മൾ പഠിക്കാൻ പോകുന്ന another important ഡ്രൈവിനെ കുറിച്ചാണ്. ഇറ്റ് ഈസ് ചെയിൻ ഡ്രൈവ് യൂസ്ഡ് ഫോർ ദി പവർ ട്രാൻസ്മിഷൻ. എവിടെയൊക്കെയാണ് നിങ്ങൾ കണ്ടേക്കുന്നത്? ചെയിൻ ഡ്രൈവ് എന്ന് പറയുമ്പോഴും തന്നെ ഈ സ്ലൈഡിലുള്ള പിക്ചേഴ്സ് നോക്കിക്കഴിഞ്ഞു കഴിഞ്ഞാൽ നിങ്ങൾക്ക് മനസ്സിലാവും. ഇറ്റ്സ് employed in wide range of power transmission applications like bicycles, motorcycles, agricultural machineries, machine tools, conveyors, coal cutters, etc. You can see a wide range of applications the chain drives are used. So the chain drives which are more suitable for small center to center distances and can be used generally up to 3 meter. Okay, so that is the chain drive. Usually this chain drive consists of an endless chain running over a special profile. Okay, so the chain drives are suitable for small center to center distances and can be used generally up to 3 meter, but in special cases even up to 8 meter. Okay, so this is wrongly written. So in special cases we use it up to 8 meter. So the chain drive consists of an endless chain running over special profile tooth wheels called as sprockets. So one of the sprocket will be the driver and the other will be the driven. If you look at this diagram, this one will be a sprocket. You can see, okay, 2 sprockets you can see. So one of the sprocket will be a driver and the other will be driven. The small sprocket is called the pinion and the bigger one is called the wheel. So small sprocket is called the pinion. Remember these terminologies. So the chain is made up of the chain which is made up of plates, pins and bushing, and what material is used for making it? The parts are usually made up of high grade steel. From the application point of view, the chain drives are classified as power transmission chains, hoisting chains and pulling chains. The main types of chains used to transmit power are, there are 2 types. One is roller chain and silent or inverted tooth chain. Let's see what is meant by roller chain. So this roller chain, and we will run the diagram, what is schematic diagram തന്നിട്ടുണ്ട്, right side ഒരു actual diagram തന്നിട്ടുണ്ട്. So it consists of rollers. It consists of rollers. You can see what here, the rollers, bushes, pins. This is a pin. Inner plates. So this is usually the inner plate and outer plates. So it consists of rollers ഉണ്ടാവും, bush ഉണ്ടാവും, pins, inner plates and outer plates. These are the main parts which constitute a roller chain. So this pin passes centrally through the bush. You can see this is a pin and it is attached to a plate and it passes through this bushing. Okay, and the roller surrounds this bush. The bush roller ഈ ഒരു ഹോളിലൂടെ ആയിരിക്കും കടന്നു പോകുന്നത്. And the roller turns freely on the bush and the bush turns freely on the pin, of course. This is very clear. Okay, so two adjacent rollers are held together by two inner plates. Okay, the two adjacent rollers are held together by inner plate or roller link plates. I mean one plate here and one plate, two inside plates. Okay, you can see this one and this one plate. Look at the schematic diagram. Okay, these inner plates are connect the bushes. Okay, the bushes turn freely on the inner plates. If you look at the diagram, you can easily understand it. So two adjacent bushes are held together by the outer plates. Two adjacent bushes are held together by outer plates, which are called pin link plates. So roller link plates inner plate ആയിരുന്നു, pin link plates ആണ് outer plates. അത് ഓർത്തിരുന്നാൽ മതി. Pin link plates are outer plates, roller link plates are inner plates. So these outer plates connect the two central pins and keep them in position. And to prevent the sliding of the outer plates, the pin ends are hammered to the shape of a rivet head. Okay, and again, in order to reduce the friction, all the surfaces are lubricated. So that is all about the roller chain. Another type of chain drive is the silent or inverted tooth chain. If you look at the diagram, different type of toothed chain is shown here. This inverted toothed chain is shown here. It consists of a special profile plates corresponding to the profile of the sprocket teeth. So these type of chains are more complex in design and require careful maintenance, and it is widely employed when heavier loads are to be transmitted and maximum quietness is desired. Thank you.